Welcome to the third video in this series building a top-down 2D racer in Godot. In this one we're going to make the bounce effect hopefully a little less buggy and get ourselves actually to bounce out towards the middle of the track, irrespective of the angle that we actually hit the collision shape on the edges. At the same time we'll also take the opportunity to build a nice explosion effect using some 2D particles. So let's start with the bouncing effect itself. To do this we need to know where the middle of the track is, or we need to know the direction towards the middle of the track from wherever we hit. And we can do this actually by adding a path 2D node and literally plotting a path around the middle of the track. And later on, this will come in useful for some other things as well. It's going to be used by the AI to have their actual routes to drive around the track, and also be used by something that's going to drop oil splats as well. So this is going to have quite a few uses for us. So what we'll do then is we'll select the root node, and then we'll add a new node, and this is going to be something called a path 2D. With that selected, you'll see that a toolbar opens here, which looks a lot like the polygon one, and it's very similar, and it allows us to plot paths and also make them also curved, which is nice. Before we plot it, I'm going to change the name of it though to something a little bit more useful. Track path is probably good. Right then, so path plotting. If you've never done this before with path 2Ds, I'll warn you in advance, it can be a little bit frustrating until you get used to it, but once you do, it goes pretty quickly. So I'm going to give a very quick demo of how it works in case you've never done it, and then do the actual path proper. So what we do with the track path selected, I'll go to the inspector and check we have a curve. Yes, we do. We've got the toolbar at the top here. We can add points using this here. Make sure you have the select tool selected. We can add points. So I can add one here, then add maybe another one here, add another one here. And then once I'm happy, I can close off the path by clicking this close curve. And that actually puts another point on top of the starting point. It's not joined anything at all. Then when you've plotted your points, you can delete them using the delete tool from here. So you can select a point and that point will then be deleted. I'll do Control and Z to undo that. We can also do select the move tool and move them around as well. And really handily, you can select this tool here, which gives you then, when you drag on a point, control points, and you can use these control points to adjust the curvature. In addition to that, if you want these to be not mirrored in this way, you can go to Options and turn off the mirroring of the handles here, and then they'll no longer be mirrored. So you can really customize the curves well. I'm going to actually turn that back on. All right then, so they should be mirrored. Yep, they are. Okay, so with that done, what I'm going to do is actually clear out this curve because I don't want it. So on the right-hand side here, I'm going to clear out the curve, and then click the drop down and make a new curve 2D, so starting from fresh. And what we need to do is we need to plot the path around here. So I'm going to start off then with the first point here. And you don't need really as many as you think. Generally, you want to be in the middle of the corners for the curvature. And we can always add points in later if we need. But this more or less should do something like this. And I'll put the final point here and then close up the curve. And now it's a matter of selecting this curvature tool and making all of these curved so they fit rather nicely. I'll position them for a racing line in a moment. First of all, I'd like to get just the curves set on these so we curve nicely around the corners, and then we'll sort out the actual sort of racing line if you like. And yep, that looks okay. So with that done, I'm going to select the move tool at the top here to select the points and move the points into a little bit more of what's probably a realistic racing line. So I'll extend these out a little bit like this. I'm going to turn off the mirroring actually now. There we go. So extend this out. So it makes more of a realistic racing line for the AI later on. We're going to use it now simply for direction. So it doesn't matter if it's in the middle of the path or not. I'll put that here, maybe extend that out like this. I'm not going to be too picky about this, partly because I'm not a professional racer or anything like that. And yeah, that would probably go around here, I guess, and we would be closer. Late apexing here. Something like this should do. Oh no, that one's miles off, isn't it? That needs to be here. One point of note is make sure that the points have a little bit of a gap from the collision shapes. Otherwise, the AI is going to crash a lot later on. You'll see that the AI won't be following the path exactly, but it will be using it as a basis. But what we're going to use it for now is simply to get the direction to this path from wherever we hit, and then we can use that as the direction that we want to spin. So let's drop into the scripts and open up our track.gd. What we need at the top here is we need a reference to our track path. So we'll grab ourselves a reference to it. And what we're going to do is we're going to grab hold of the curve on that, and we'll put that actually in a variable so that it shortens the code a little bit later on. So I'm going to call this a track curve. That's going to be of type curve 2D. And then we're going to use the ready function to actually set that. So do func and ready. And then we can set our track curve is equal to our track path.curve. And we can actually use our curve now to ask from a given point, what is the closest point on the curve itself? So we'll write ourselves a separate function to do that. So we'll write a function called, and I'll call it get direction to path. And as a parameter to this, we're going to take the from position, which is actually going to be where we are when we collide with the wall. And the return type here is going to be a vector2. Doing this is a two-step process. If we go to the 2D view, Godot calculates the length of the curve. Let's say it calculates 1000 pixels. And as you follow a curve, if you use a node to do it, you'll use something called an offset. That's literally how many pixels along the curve you are. Now the curve itself is actually made up of lots of little points. If you click on the curve on the right hand side, you'll see the bake interval. It's made up of points every 5 pixels. So what you can do on a curve 2D is actually give it a point, any point you like, and say what's the offset that's nearest my point. So for example, if we were, let's say, crashing here where the mouse is at this little point here, let's say it is a 1000 pixel long curve, we'll probably have the nearest offset, say around 500 pixels. Once you have that offset, you can then query the curve for what's the nearest point to that particular offset, which will be within plus or minus 5 pixels. What we have then is the nearest point to where we've crashed on this particular path, which we can use to get our direction that we actually want to bounce in. So we'll be bouncing out into the track. So go back into script view. So we'll make a new variable, which is going to be the closest offset that we have, and we'll set that equal to then, and we want to get hold of our track curve, and there's a function on there called get closest offset, and we send in our from position. This will get the offset in pixels along the track. I'll go to distraction free mode. Hopefully you can see things a little bit better. Now we have that closest offset. What we can do is we can get the nearest point along the curve to that offset. So we can say var nearest point is equal to, again, we grab hold of our track curve, and this time we do sample baked. This will sample the baked points. The baked points are the calculated points of the curve, and we send in there then our closest offset. This is then the nearest point on the curve from the position that we've crashed, which will be our from position. So what we need now is the direction to that, and that will be a vector of normalized length, so a length of 1. So we can return then our from position, and we want then the direction to the nearest point. And we can use this vector that's returned here then to know which direction we need to bounce in. So what we'll do then is inside the hit boundary, we haven't got a parameter set up yet, but we'll already send in the get direction to path. And here we can send in the area.position. Now, we'll say one thing very quickly actually about positions. If I come out of distraction-free mode, hopefully you can still see that, you're probably typing. I've used position here, and in fact, inside the car.gd also used position as well, wherever we've used it anyway. Where are we? Here, position, for example. And I haven't used global position, which you often see used. So in case you're not aware of the difference between the two, the position is the position of this node relative to its parent. But it just so happens in this case that the car's parent is the track, which doesn't have any position. So the car's position is the same as its world global position. I thought I'd point that out because a lot of examples you see global position here. In this case, we don't need it, so I've stuck to position. Anyhow, what we've got now is a normalized vector, so a length of 1, which is the direction to the middle of the track from wherever we've just hit, or from wherever the car is as it's just collided. So let's drop back into the car.gd then, and go down into our hit boundary. So we need to update the signature of this now to take in the direction to the path. And then what we can do is send that direction to path into our bounce here. So I'll copy that and scroll up here because that needs it as well. And now we can replace the minus transform.x with the direction to the path. And this should have us bouncing rather nicely now out into the middle of the track. So I'm going to take a deep breath and run this and see what happens. So if I go into this, what happens? Yes, we're bouncing out into the middle of the track. Cool, that is much, much better. Incidentally, if I press F8, you can go to debug visible paths and actually see the path as well. That can come in quite handy to know where it is. So let's try here. Yeah, let's try actually going right on the point here. Can I break it by doing this? In my testing, I couldn't. But, oh, you never know, and I can't reverse there, so I've gone past that one. Let's try here. Okay, no, we're all looking pretty good here, I think, actually. We can go backwards around the track. We'll deal with that later on. But that seems to be working a lot better than it was before. The only thing is, I don't like the spinning. It's far too slow. So where are we? Where degrees here? I'm going to make that 720, I think. Here, try that again. F5, does that look a little bit better? Okay, yeah, that's much better. Cool, so that's the bounce effect almost done. What I'd like to do now to finish this particular video is I'd like to add a bit of a particle effect into this so we have a nice sort of explosion effect. So let's drop to our car scene, and with the root node selected, we'll add a new node here, and we want to look for the CPU, and you should find CPU particles 2D. I'll call this a crash effect. And then you'll notice on the screen here that we've got these particles dropping automatically here. So on the right hand side, let's open up a texture here and we'll find the dot here to start with. Now dots are a little bit big as they are like this. So let's go, if you scroll down, you'll find here the scale section. We'll scale this from 0.01 to I found 0.03 being okay. So we're going to get them randomly scaled between 0.01 and 0.03. Which I think looks all right. Then what we can also do is we can affect this over time. I'll drag this over to the left like this and make a new curve here. Click on the curve and everything disappears because over time, so the lifetime of the particle is the x here, everything is now at 0 scale. But if you click and drag this line up to the top, we can now manipulate this line and start off, say, at half size, stay full size, and then towards the end we can sort of disappear. So towards the end of the life of the particle, its scale will drop. You can't see that too well here, but we will do when it comes to actually the more explosive effect. All right, then, so that's that done. The other thing I'd like to do is turn off the gravity, because they've got some gravity, I think, yes, applied to them, which is why they're dropping downwards. So now all being emitted in the center of the car. We can't really see anything. So what we can do then is give this some velocity as well. So we'll give it some initial velocity. And it's really up to us what we want to choose here. I'll choose maybe 50 pixels, and then we can do between 50 and 80 pixels a second. So we've actually got something coming out. Let's make more of these. Let's make 32 of these. We've got quite a few more. That's better. We want these going sort of all directions, so we'll spread these over a direction of 180 degrees in the X, which should have everything sort of bursting outwards like that. Talking of bursting, they're not really bursting. If we go to the time section here, you can drag the explosiveness up to 1 if you want them all to come out in bursts, but I found here about 0.75 or something around there, a little bit better. It's just slightly more gradual. They are going maybe a little bit quick here. I can always tune that later on. Let's have a look at what else we can do with this as well. So we could give it some orbit velocity as well. You have to be a bit careful with this, but if I do -2 to 2, yeah, that gives a little bit of a better effect. I'm wondering if they are a bit fast. Drop the velocity to 30 to 50 maybe. Yeah, I think that's better. Okay, and we can give them some radial acceleration maybe as well. This has to be quite high, this value, so I do 80 to 100, and that should have them accelerating outwards a little bit as well. That's quite nice. Maybe it's a bit too much, actually. 40 to 80. Over ambitious, there we go. And then finally, actually, I think we're nearly there with this. We could give this a color as well. So if we select the color down here, I'll drag this down and just find some kind of reddy, orangey color, something like this, I think will do. That seems to be about right. Okay, so I'll do Control S to save. That's our effect. The effect, maybe we can drop the lifetime a bit as well, actually, maybe to 0.6 seconds. Oh, that's better. Okay, so that's the kind of thing that I'm going for anyway. It doesn't take too long to set these things up. So what we can do then with this is actually make this one shot. So it just happens once, and we'll leave the emitting obviously off. And what we'll do in the code is start this whenever we crash. So let's drop into the script view then, and right at the top here, what we need to do is drag in a reference to the crash effect. So I'm going to left click with the mouse and then hold down Control, let go of the mouse, and we have the onReady crash effect CPU particles 2D. Incidentally, if you don't see the types here, because I know sometimes it's not there depending on what's happened to you in your system, you can go to Editor Settings, and do Type here. And if you go down to Text Editor Completion, you might find the Add Type Hints is turned off. It should be on by default, but sometimes people get in touch to say it seems to have switched itself off. If that happens to you, that might be why. So I'll close that down. Now what we can do is we can emit our particles whenever we crash. So what we'll do before we go into the bounce is we'll do crash effect dot and restart. And that should emit our particle effect when we crash, which we're about to find out. So I'm going to run the game and then turn this way. And do we get it? Yes, we do. Cool. Okay, it could be a little bit brighter, maybe. But we've got a nice particle effect coming out there, which I think is pretty cool. We don't have any sound or anything like that. We'll add that later on, but we are getting our nice effect. I'm going to press F8, close that down. The color of that is a little bit dull, isn't it? And you've probably realized by now that I'm not a good designer. And with the magic of editing, you won't have noticed, but I've been away to have a look what I actually prepared, and it was 255 131 64 was a better color. I'm being a little bit pedantic here, but okay, yes, that was more the color that I was going for. All right, so F8 to close that down. And we've come really far, actually, with the car. We've still got some more things to do, like lap times and things like that, but in terms of overall control, that's pretty much it. What I'd like to do in the next video is turn our attention back to the track. When we play the actual game, we're going to have these oil slicks being dropped, which will make us spin when we hit them, and in the next video, we'll see if we can get that up and running.